bit of framework. So this is the system as either STL files or a feature that's up and coming will be scan to CAD. So if you have a part and present it straight to the robot, you're be able to scan that part and reconstruct the CAD model from that to make use of it inside the system. So you don't necessarily need to have the CAD files. But typically, it's better off if you have the CAD files, they're usually more accurate. So once the CAD file has been presented to the system, you can train it in one of three ways. You've got a CSV file, so from your CAD modeling software, be it SolidWorks, Solid Edge, or Inventor, and others. You're able to select the edges that you want to operate on just within that software, export those using a third-party application that come with the system, and that will give you a CSV file. Loading that CSV file into the system will then allow the system to identify which edges you want to run and which parts you want the system to take. The second method, which we'll show in a little bit, is demonstrated on this part behind you. That uses marker training. So you present the part to the robot, and with a standard blue paint marker, you mark the edges that you want to actually run. The system will go through, scan the part, and identify from that which edges that you want to operate on. The third option for training in the system is with hand training. Specific to collaborative robots, we provide a handle that's going through a couple of revisions at the moment. This will connect to the rig of the robot arm and allow you to drive the robot manually into position, tweak and tune where you want the operations to be, tell it, I want to go through these set of points, other situations like that. So very similar to this one in a way, but just integrated within our system with a couple of extra features. So, on the user interface, we have a couple of portions for the screen. On the left-hand side, we have the hierarchy and training parameters. So the hierarchy shows you which parts and features have been loaded into the system at any point in time. So this is either done through adding the part manually or by scanning the system. These show you there, if there's multiple parts, each one will show up in the screen, allow you to select between all of the features of that part that need training, and then go and train those operations. The next section is the parameters. So the parameters are actually what you're tuning. There are quite a number of them right now, however, there are only 3 or 4 parameters you actually need to tune correctly to actually get the system up and running, and that's what we want to limit things down to, is just a couple of parameters. In the center of the screen, we have the simulation view, or the digital twin of the system. So this is set up as a representation of the cell itself. So this will show you the robot, everything it's equipped with, everything it sees within the cell. If you've got tables or obstacles inside the system, each of those will be present and configurable. And on the right side, we have all the controls. So, for this case, just to demonstrate the end result of what we're going for, and then we'll dive into a couple of bits and pieces behind it. What I'll do is I'll show you run of the system. So the system has a number of run modes. Simulate, cold, and hot. Simulate run will run the robot in the simulation itself, and that will just show you on the digital twin what the robot intends to do. The cold run, which we're about to see here, is the robot itself going and performing the operation, but it just won't turn on the welding torch. The last one is the hot run, which will be exactly the same as the cold run, but actually turn on the welding torch. So, probably best to get